Yeah, good morning, everyone. Welcome to this FarmConners Consortium meeting. We are having the usual, the more or less usual ground rules for online meetings that we've had so many of over the last few months. Especially since we're not that many people, I think we can just turn on the camera when we want to have a question, and otherwise just shut off the camera. The other possibility is to post the question to any talks in the chat, but I think, as I mentioned, we're better off with having direct conversations. This meeting is going to be put on our YouTube channel, but as unlisted, which means that it's quite unlikely that people just stumble over it because it's not within any of the search functions. So you need to know the link to know it, and I'll just circulate the link here to our group. Yeah, and that's it so far. There has been one clear highlight, and that's the publication of the benchmark, which is on that YouTube channel. And other than that, I'm going out of the way right away. I did my dues for the moment, and then we'll head on with Filippo.
Thank you, Gregor. So I will share the screen.
Yes.
Okay, is it visible?
Yes.
Okay, so the idea of this presentation is to update the partner of the consortium concerning the progress on the work package 1 that is about testing and validation. And specifically, what I want to do is with this presentation is to look at recap what we promised, which were the objective of the work package, which deliverables. So I took the grant, I look at which were the objectives, the deliverable that we promised, and what we did, and what is left to do. So what still we have to do. So the objectives of the work package, of the first work package was the main objective was to increase the confidence in the models and the control strategies that are used when it comes to wind farm control. And there were 3 main objectives, which were aggregate the experience of the past and ongoing activities in test and validation of wind farm control strategies, design a benchmark, a FarmConners wind farm control strategy benchmark for testing the models and strategies available, developed by the partners, and perform a further validation of the available models and strategies through the benchmark so as to increase the confidence in the technology. So this means that we had 3 tasks. The first one, task 1.1, was about state of the art, was led by Senair, and participants were all the members of the consortium. And the goals were to establish the present state in testing and validation of wind farm control strategies and models, define available measurements and data sets, validation data sets, and define open challenges and research gaps that still has to be investigated. So there were 2 deliverables that were due concerning this task. The first one that was deliverable 1.1 was to organize a workshop on the research gap, or to analyze the research gap on wind farm control demonstration. And this was done in Amsterdam. So at the kickoff, 2 days kickoff meeting. And the second deliverable was again to present the outcome of this research gap analysis in a talk paper. And this talk paper has been accepted, so talk 2020, and is the paper whose lead author is Jan Willem, and the title is Expert Elicitation of Wind Farm Control. So the task 1.1 has been completed. Then task 1.2 was to design, the goal was to design a common benchmark, and there are several participants, and the goals, the objectives were to define the most relevant scenarios to test and validate the available wind farm control approaches, and evaluate the available models by grouping the benchmark cases depending on control strategy, control design and the objective of the control strategy, so power maximization or load reduction of both, define evaluation criteria, and present the benchmark at Torque 2020. Again, so we had several free deliverables. The first one, deliverable 1.3, was to define consensus on common test benchmark case for code comparison. Again, this was reached during the 2 days kickoff meeting in Amsterdam. And write a white paper, so an open access paper with recommendations and best practices for testing and validating wind farm control strategies and models. And this has been submitted again. And finally, deliverable 1.4 was to launch common test benchmark case for code comparison. And in this regard, a paper that discussed the benchmark has been accepted for being presented at Torque 2020. And it's a paper where the main leading author is Tufe, and the title, as you can see, is Launch of the FarmConners Wind Farm Control Benchmark for Code Comparison. And also we launched a webinar, so we presented the benchmark, the FarmConners benchmark, in a webinar that was held on June 12th, 2020. So now I think I would like to lead to have Tufe presenting what we did in terms of the benchmark, how we designed the benchmark, and what is required to participate, to join the benchmark. So Tufe.
Thanks a lot, Filippo. Yes, so as Filippo mentioned, you can hear me, right? All of you? Lovely. Okay, so as Filippo mentioned, we were supposed to have the launch of the benchmark in Torque 2020, but because of the COVID, the whole conference sort of postponed, and it also changed the format to be online. But our deliverable time was actually also for May, June, so we didn't want to take further risk on extension or a little bit of postponing of that deliverable. And it was also important for the timing, because the output of that benchmark was supposed to go for the Wind Energy Science Conference 2021 next year, approximately this time next year. So we wanted to give enough time for the participants to be in. That's why we decided a webinar would actually be a good idea, given this online times, the new normality. So we did that 2 weeks ago. And we recorded the whole thing just like we're recording it right now. And we have the Wind Farm Control YouTube channel up and running. This is actually a clickable link. So after we were sharing the slides, you can go and see the whole webinar for yourself as well. So it was about 35 minutes video, I think. And the slides are separately available as well on SharePoint for the people in the consortium. You all have access to it anyway. And that's interactive, that's in the PowerPoint format. But if you want to have the offline version in the PDF, you can also reach that through that link. So it's been 2 weeks since we launched it. And so far we have 4 official registrations. And that's to all the cases. So for all the test cases, for all the provided data sets underneath those test cases, we're not sure what type of models the participants are planning to use yet, but we will get that information when they're actually uploading their results. I'll go through them briefly in a second also. So over those 2 weeks, we've been getting also several emails from the separate interested parties. Some people even called me, but they're not yet officially registered. So please spread the word further. And we will also go a little bit over why we want you to register as soon as possible, because I can actually give you the data access already now. So it might be important for you to get familiar with the data, or for the people who are interested to get familiar with the data as soon as possible. So next slide, Filippo. Within the benchmark, we actually have 3 platforms. So the first one is the Git repository that is actually public. It includes some example cases, and it's actually feeding the documentation that is also going to read the docs. Next arrow. That's the documentation that the Git is attached to. And that's a version tract. And that is pretty much the most detailed document we have about the benchmark. It includes pretty much everything that we mentioned on the talk paper itself. But on top of that, it also has some practical information, some frequently asked questions and the responses to that, as well as a registration form where you should use if you want to participate in the benchmark. And then after you register, next arrow, you will actually get a link to a personal cloud folder where only you as a participant will have the right access. And then the people who are in the benchmark organization committee is going to have the read access to it to be able to read your results in the end. So what's happening in that platform is that the participants cannot actually see each other's results. So everybody is only having their own personal folder. And the participation is anonymous. Also, the publication of the results will be anonymous. So the next slide. Yeah, so we thought it might be a good idea to show you a little bit of a demo, what we actually have in the Git, and also what the documentation tells you. So I will take over the screen. I think we both can share at the same time, but let me try. Can you see the screen? Is the Git on?
Oh.
It's not here?
Oh, we can. Maybe, Filippo, you have to stop sharing.
Okay. So I stopped sharing now. Has everybody stopped sharing? I'll try again. Can you see it now?
Yes.
All right, brilliant. So that's the Git page we have. And then in the docs, that is directly relating to everything to read the docs, the actual documentation itself. And then there is the example cases where you can find underneath. So we have one example case for the SME wind farm field data, and we have one example case from the CLWinCon LES data. Those example cases also sort of being able to run standalone. So they have a snippet, like an example of the data set, like a small part of the data set itself, very small though. So the Git itself is going to lead you to the documentation right here. So FarmConners read the docs.io. We have also linked it through the main webpage, windfarmcontrol.info. If you click on the benchmark, this will actually refer you to this page, which is the documentation. So within the documentation, we have also already put the online recording links and the repository itself. And then you can find in the navigation pane all of the details about the benchmark itself. So it starts with the provided datasets. And underneath the provided datasets, we have the larger simulations coming from both Total Control and CLWinCon. We have the CLWinCon wind tunnel experiments, in farm field data, and then there's a summary, a little table. Similar organization from the paper. So if you click on each of the sections, you can go and find more detailed info about the provided dataset itself. And then after those datasets, we have the test cases. So within the test cases, we have defined single full wake under wind farm control, which is a basic configuration. And then we have the single partial wake under wind farm control, very similar to the single full wake, but they actually have this lateral distance between the two turbines. And then we have multiple wake under wind farm control. So that's like a several turbine configuration. And the spacing between the turbines are not necessarily uniform. And also the spacing between the turbines are changing per data set. You can see for the wind farm field data, for example, we have several different diameters. And then for total control, it also changed 5D. And then for CLWinCon, we have different spacings. And for the wind tunnels, we have different spacings, for example. And for all the data sets available for each test case, they also have different control settings. Some of them, for example, wind tunnel experiments include both the axial induction and also wake steering. But wind farm field data have separately axial steering and axial induction and wake steering controls. And for some of the total control LES data sets, it's going to be only wake steering or axial induction. And CLWinCon LES, the cases we have chosen are only including wake steering. So these are pretty much the test cases. And within the test cases, you can see per test case the available data set. And maybe what's more important at this point is the expected model results. So what to upload per test case. So before maybe we talk about this, let me mention a little bit of the quantities of interest we want to look at the end of the benchmark. So everybody is running this configurations, right? Single cases, a single case with a lateral spacing, and then multiple wake case. But then what we want to see at the end of the day, we have discussed over this in our previous meetings, in the consortium meetings. The first one is the power gain, which is quite common as a quantity of interest as a validation metric. People have been using that a lot, so it's normalized by the normal operation. So we're looking at the power under wind farm control, the sum of the power, the aggregated power, and then we normalize it by the normal operation power, and then that should give us the power gain. You will look all those quantities in terms of their medians and the spread. So it could be percentiles or it could be the whole distribution, depending on the model capability that people are running as participants. Then the second parameter we wanted to look at was the wake loss reduction. That is also giving us a little bit more room in terms of avoiding the errors that might come because of the conversion of wind speed to power. And then we have the third as the reduction in vacated turbulence intensity. So that can give us a little bit of an idea in terms of how the loads might be elevated, especially for the models that are not necessarily coupled with any kind of aeroelastic tools. And then load alleviation, if it's possible for the people who are participating to provide that info. We are also asking channels regarding that to be able to calculate that. So coming back to the test cases, what kind of expected results we have per data set, for example, for the multiple weight case. This convention is also following up pretty much the provided data sets per case. So for the total control, for the Siavincon LES, for example, the turbines are called T0, T1, TX. That's why we are going to TI notation, and we want also the participants to use that. Similar approach for the wind tunnel experiments, similar for the wind farm field data, where all the turbines are labeled as SMV1, 2, 3, 4, 5, 6. So this is a detailed list also for the participants that can actually follow it. If there is any question about the taxonomy or what certain symbols refer to, they can always come back and check here. And there's a new page, fairly new. We put it after the webinar itself when the questions started coming up. It's in this fact page. So you can find some questions we've been getting, sometimes more than once. We put some of them here. And then the most important part is how to participate at this point. And we have the registration form right here. So after you have a good read on the test cases, and you fill your personal information first, of course, and then you start choosing the data sets per test cases. Let's say you're interested mostly in multiple wake under wind farm control. You can choose as many as you want, as many data sets as you want. There is no upper or lower limit in terms of the number of test cases or the data set you need to choose. But we expect you to submit results after that. The only sort of non-open or NDA protected data set we have is the wind farm field data coming from NG Green. And you see there's also a little star attached to this. So if you choose any of that, if you click on any of this, two data sets, then you're expected to follow the instructions given for this NDA template here. So you're downloading the template over here, and in the first page there are instructions, you're filling them out, and you forward that to the NG Green people after you submit this report. So when you fill it in with your personal information, chosen test cases, and submit, we as benchmark organizers, we all get an email, and then we register you, give you a participant's ID, and then get back to you with your personal cloud folder, and also with the links of this particular data sets that you asked access to. So this is how the documentation kind of works at this point. I think we can get back to your slides now, Filippo. But if there's any question regarding documentation, maybe it's also time to take that.
Okay, it seems like not. So we can, now you should soon see again my screen.
It's on, yes.
Yes.
Okay, great.
All right.
Okay.
I think there was one more I wanted to, yeah, exactly.
Yeah.
So it's a little bit like an overview on what to upload for the benchmark. And remember, there is no deadline to register for the benchmark itself, but there is a deadline to submit your results, and that's at the end of the year. And then the brief, okay. Oh yeah, Thomas just mentioned in the chat that the FarmConners Consortium people, they don't have to sign the NDA because it's already covered in the consortium agreement. I think that's what you wrote, right, Thomas?
Yes, exactly.
All right, brilliant. Okay, so in terms of what to upload, minimum for all the models, they should be uploading the power produced by the turbines. 2, if it's one of the single weight cases, or multiple turbine cases is going all the way to 8 turbines. And then we expect participants to upload hub height and or rotor effective wind speed at the turbines or at the measurement locations. For example, for the wind tunnel, we have the wind speed profiles that is taken at certain downstream distances from the first or the second turbine. So we expect participants to upload the hub height or the rotor effective wind speed, sort of spatially average wind speed at those measurement locations as well. And of course, they should be indicated accordingly in the upload file. And very, very important is that the first thing before the parameters is that there should be a brief description of the model used, including the references to certain papers to the model if the model is published. If it's not published, we want this brief description to be a little bit more extensive, and so that it is clear enough for the people or for us to understand what we are actually comparing all the models against. And then if the model has slightly higher fidelity or capability to be able to couple with aeroelastic tools, then we expect the participants to submit some load parameters as well, and that's flap-wise. That's the vectoral sum of the shaft bending moment, and then vectoral sum of the tower bottom bending moment at the turbines. So as I showed you in the documentation, there are clear instructions per test case, which parameters to upload, and loads are sort of optional if your model doesn't have the capability, but minimum we expect you to upload power and mean speed. I think that's all I wanted to say for today. Back to you, Filippo.
Okay, thank you. So we can see that also the activities that were foreseen for task 1.2 has been completed with the launch of the FarmConners benchmark. And the next, the final task of the work package 1 is task 1.3 regards the results that we will obtain through this common benchmark. So in here we're going to have participants outside of the consortium, probably or hopefully, but also we have participants within the consortium. So you see that there are many participants, many of us, and the goal of the task is to validate models against the database. As we see, 258 consists of 5 fidelity simulations with 10 experiments and field tests. So we want them to use this database to quantify and reduce the model's uncertainties and by further training the models. And we expect to gradually converge to identify which are the wind farm control strategies and methods whose benefit we can rely upon. So we can rely on the so we can identify the strategies that can provide major benefits. We can see if there is an agreement among the predictions of the models that we are going to use after they've been validated and trained. And the idea is also to compare model performance and results in a journal paper, hopefully in Wind Energy Science, to be presented in the Energy Science Journal. So this is the task that still requires some activity from all our side. And we'll have to produce 2 deliverables. One is due by June 2021 and the other August, so the end of the project. And so we will have to present the results of the common test benchmark as a side event at Wind Energy Science. This is what we promised that we'll be holding Wind Energy Science Conference that will be holding 2021. And we will have to have the results publicated, so to compare the models and the control strategies. And this is again has to be due by the end of the project, that is August 2021. So concerning the next step, I already sent a request to all the participants in the task, because I think it's important that we already start thinking about which model or models are we planning to use for the benchmark, and also which data sets among those that are being provided for the benchmark are you going to use, or are you planning to use for the blind comparison. So I sent this request, and I wonder if the partners that are involved in the task would like to say something about this. Again, we understand that this partners are still thinking about, but I think it's useful to start initiate the discussion because, as Tufa said, in the end we need to produce results by the end of this year. So it's time to really think and focus, and especially remember to register as soon as possible to get access to the data and get familiar with it. So I would be glad to let some of the partners speaking. I don't know if someone wants to start first.
I can say something if you want to.
Yes, thank you.
So we are working at the moment also in the context of total control and some other projects on a new wake model. Well, it's not a new wake model. It's basically integration of existing wake models in a new merging approach, and also a coupling to the atmospheric boundary layer. So also a simplified model for that. And this is something that we definitely would like to test here.
Okay. And so you think you test against wind tunnel, or?
I think actually we'll need to see, right? But I would imagine that we test it against everything that is available. I mean, the model itself is pretty fast. So it's just a matter of getting, it will depend on how complicated it is to kind of, get all the data in a good way out and set it all up. But my expectation is that we would try to test it against everything. But don't shoot us if we don't.
Okay, but because I think as I said, it's important that we start discussing, because hopefully we will have participants, because we need to provide a comparison between models and the data set we made available, and hopefully we'll have participants from other institutes. But it's important that we commit.
So I think what we kind of, we hope to submit is, we're working on a first publication on this model. And we have already been working on, taking wind farm data from all kinds of like historical data, let's say. And I think what is useful and that we could also try to do in this benchmark possibly is not just showing, test case by test case comparison, but more showing like a little bit like is done in I think the climate community, showing the spreads of model errors and the bias of model errors on average, and kind of giving more like statistical distributions of model quality over a wide range of possible cases. I think that can be interesting. So that's also why I think that we would try to do everything, but I don't know whether we will succeed. But at least from the model side, it is pretty fast, so that should be no problem.
Okay. Okay, thank you for the update. Then from DTU Senair, I know that TU Delft, no one I think is participating today.
Yeah, so from TU Delft side, both Jan Willem and Bart, they couldn't make it for today, but we can also ask separately to them what they're planning. For DTU, I can say a few words, I guess. We are planning to join with hopefully several models. What I have personally in mind is to have a surrogate, so it's going to be sort of no fidelity approach. That's what we've been working on for many years, and use this sort of already learned and already trained model with some transfer learning with the new data set available to see to test those capabilities. That will be interesting to look at for us, and from that we can get both the power and the load quantities, and that's one thing. So I think also I heard that there is interest from with Fuga, a recent paper maybe you have seen, especially for the extrusion cases. They wanted to try that out. And there is also the new development that we're having is a bit like fidelity-wise is closer to fast farm. So it's sort of mid-fidelity DVM coupled with POC2, and that will also be used for some of the cases, but I'm just not sure which ones will be the most suitable for that yet. But we're thinking about it. So that's the three I know from the DTU side.
Okay. And you're planning to apply to wind field data, wind tunnel data, or?
I think for Fuga, they are planning more for the wind farm data because it's a little bit, it's lower fidelity in some ways. But for the data driven, it doesn't really matter. So I want to try it with all the, the more the merrier, right? And then for the DVM model, they might need a bit more detail on the turbine model and so on. So I guess it will be a good idea to use it for the CLWinCon LES dataset and the wind tunnel.
Okay, thank you for the update. Then I don't know, Senair or for wind, or even DNV GL. Irene, we cannot hear you.
We can't hear you.
I don't know. Now?
Yes.
Okay, perfect. So for Senair, we are still discussing on how we are going to approach the benchmark, but probably it will be with a low fidelity order model, like, for example, Floris, which is one of the candidates, and also thinking, as the same Tufe was commenting before, either on the wind farm data or the wind tunnel data. So we are still discussing, but those are the main choices right now.
Okay, Thank you. So it's good that we have already, say, very different models. That is definitely is going to be very useful because we will have predictions of things with very different models, so different derived in different ways. So from CFD, data-driven, or engineering models, and this is very, I think, important for a comparison. It's also for doing what. So what has been said before, to try to assess the accuracy depending on the, for example, the computational cost or how the model has been built. Okay, and what about Forwind and DNV GL? Any clue?
Hi there, this is Renzo from DNV GL.
Hi, Renzo.
Hi, so we've been thinking, well, we're actually still thinking about what to focus on at the moment, but I believe that the wind farm field test case will be the best test case for us to test. I'm not sure yet about the LES and wind tunnel data at the moment. And I think we're going to test, first of all, a number of different sort of simplified state models, wake models. Eventually, I believe that we're going to use a stability modified Gaussian model, and that's for steady states. And then most probably we're going to also run some dynamic simulations using our stochastic embedded turbulent field model, so long sim essentially, for a few chunks of data, I believe. But anyway, yes, we are still discussing about this more in details. So we are likely going to end up with a final decision in the next couple of weeks, probably.
Okay. Thank you. Thank you for the update. And I think finally, the last participant, Forwind.
I don't think there's anyone from Forwind on the call.
Okay. Okay, so I think we will have some update from them via email. But I think it's important. I'm glad to hear that we have already quite planning. So a lot of participants with very different models, with different data sets, of course. But this is very, I think, promising. So I expect that we have good, a good outcome of this activity.
I have a question actually. So our model actually is not at this moment including the elastic part. I mean the fast model that we would use. Is that a problem? So we would focus basically on power predictions. That is all right.
That is fine, yes.
Yes, absolutely fine. So it ideally, we said it's possible to look at both. So look at power and loads. So we expect that many codes are not capable of predicting loads. So almost all codes are capable of predicting power. Just few of them will be able to predict loads.
I guess once you, I mean, if you predict power, or essentially if you predict the inflow to the turbine, the mean inflow to the turbine, then there's obviously standard add-ons that you could use to predict loads, right? I mean, and then you can improve on those. So I don't know, I wonder even whether it might be interesting to pull those apart almost, or yeah.
Yeah, it's just that, yeah, I agree with you. It's just you need to get to capture completely the flow, the inflow. So not only the average speed, but turbulence or shears or eventually misalignment. So if you can capture all these quantities, then I agree with you. Then if you have your tool that is computing load, your external elastic simulator that can get load, if you can capture those, so the profile, the inflow characteristics very well, and I agree that the outcome of the loads will be, you should get the loads right. I agree with you, but it's not that easy. Or not all models can predict all the inflow characteristics that are required to properly capture the loads, properly reproduce, compute the loads.
No, I agree with that. I would argue that we don't even know what characteristics we really need to capture and which ones are not so important, right?
Yeah.
Yeah. I think that the trick is to add more and hope that it is enough.
Exactly.
That's true.
But I would also like to add maybe, I mean, we have in an attempt to simplify it a little bit, we have added this extra quantity of interest, right? Looking at how the turbulence intensity, edit turbulence intensity is changing in the wake profile. So maybe that can already give us some trend because at the end of the day, for example, for some data sets, well, actually, apart from the wind tunnel data set, we don't necessarily have the measurements for the loads. So the comparison or the benchmark for that matter is not going to be against a true value, if you will, you know, because with the LESs, we will also have the potential. So it will be, for example, for the Siavincon LES, it will be all the load models against fast run given the condition, right? And then for the total control LES, for example, in DTU setup, it will be all the models compared against flex. You know, it's also a little bit tricky because we don't have the field measurements necessarily for the loads that we can compare against. So it will be that kind of benchmark. It's not necessarily super validation, but it's more comparison, I would say.
Yep.
I just want to mention that we do have the loads for the wind tunnel experiments. So it's a valuable data set from that point of view, yes.
Exactly. So apart from the wind tunnel, we don't have that.
Yep.
So that
Yep.
is, yeah.
Sorry, Irvin here, just to clarify, so the wind farm field data does not have loads, is that right?
Yes, right.
Okay. So if there are no other questions, I think I finished 5 minutes late. I don't know if there are other questions, or we can, like, I finished 5 minutes earlier, sorry, like save some time. I think it's always useful.
Filippo?
Yeah?
I think you have not mentioned what we plan on doing.
Sure, agree with you. So we also plan on using, let's say, a augmented version of Floris that we have been developing in the recent time. And we are planning to use at the data set the data that we got from the wind farm, the data provided by the NG Green. So we are going to also use Floris, but modified version that we have been working on, and specifically on the wind farm data. So we're still, however, thinking details about this. We are planning to dedicate some resources, like PhD candidates or having a student supervised by one of our PhD candidates. So this is also what we plan to use, what we plan to do for this task.
Filippo, what's the new thing in that Floris version that you have?
In the Floris version that we have been developing, we have implementing non-homogeneities in the flow field. For example, what you can get, we have orography, so orographic effect. We have implementing we have including the accelerations that you can get outside of the wake, secondary steering. Some of these features are also now included in the last release of Floris. But some other, we have some differences in the way we are modeling. For example, the not homogeneous inflow conditions within the wind farm. So there are some differences among the two versions.
But may I?
Sure.
Yeah. No, I think there is a radical difference. In reality, what we're doing is we're augmenting a baseline Floris with correction terms, and then we're using machine learning from data to learn these corrections to Floris. So this is very different from the latest versions of Floris that include the effects that Filippo has mentioned as directly modeled. Our approach is, I think the guys at DTU are using a purely data-driven approach. We're using a hybrid method. So we're using a baseline model, whatever it is. At the moment it's Floris, could be whatever you want. And then we're surgically inserting correction terms to this model. And then very pragmatically, we're learning these correction terms from data. So you result in a hybrid model. We think this is very powerful because you have an initial baseline performance coming from your initial model, and then you have only to learn the correction terms. You don't have to learn everything there is to it, but only the small errors that you have in the model. So it seems to be working very well.
Really cool, Carlo. I'm super excited to see that. Maybe it's a good cue for to mention also that because I forgot to say, in the benchmark itself, there is actually the blind comparisons and there's also the calibration period. So we have sort of two exercises for that. We are providing calibration period in the data set, which is mainly consisting of the normal operation and maybe 1 or 2 controlled cases. So that, for example, if you're using Floris and if you're sort of using a little bit more old school version, then you might want to adjust some of the Jimenez steering parameters, for example. So 1 or 2 control settings in closer to the borders, and then the normal operation for the calibration data set. And then for the blind data set, you're only getting the input. There is no output to the models. And you are supposed to provide the outputs in the expected output list. And then it's going to be the blind comparison according to that.
Could I ask a single question to Carlo about your new model there? So the question is, what kind of data set do you use for learning your model?
We have used just standard SCADA data on real wind farms. For example, we have a paper out in Wind Energy Science where we demonstrate this method using a Sedini wind farm from the CL Windcom project. So that's purely very standard SCADA data, nothing special. We have also used the same technique with wind tunnel data. In that case, we can simulate SCADA data in the wind tunnel, but we can also use extra measurements that we can get in the wind tunnel. So it's again very flexible. Depending on what you have, you could feed the model different data sets. Of course, typically in the field, it's difficult to have a lot of information in addition to standard SCADA. Maybe in the future, yes, you could also have something more. We are trying to develop things that might be applicable also on existing wind farms without extra equipment. So the initial focus was really on just using purely SCADA data and nothing else.
Okay, super. So it's more high-level data and not so much in detailed in the flow pattern and stuff.
No, exactly, yeah. So when it is SCADA data, it's basically power and the standard things that you have. But of course, as I said, in the wind tunnel, for example, we have a lot of extra information. We have wake profiles, you have loads, you have lots of stuff. And then in principle, you can include all this in your learning process. So it depends what kind of data you have and what kind of error correction terms you want to learn. But for example, if you take a look at this paper, it has been just accepted in Wind Energy Science. It's quite interesting that we were able to show that starting from a Floris implementation that does not have secondary steering, we were able to learn secondary steering purely by looking at power, nothing else. Of course, you need to have enough data points. Yeah, it's clear that, you can only learn what you have in your data sets. But again, I think since that's the problem of whatever machine learning technique, no matter how sophisticated it is, you can only learn what is in the data, nothing more. So that's why we like this sort of hybrid approach. So you already have some initial baseline capabilities coming from your white model, let's say, and then you only have to learn those extra terms. And I think this also eases a little bit the requirements on the data sets.
So it's a little like a perturbation around some basic model.
Yeah, it's not really, it's not a white box, it's not a black box, it's what you would call a gray box. So it's, baseline plus corrections.
Yeah.
And then, of course, you can be creative with the corrections that you want to insert. And then, of course, there is also another interesting point, because the more corrections you bring into the model, the more parameters you have to learn. And so you might end up with parameters that are not identifiable because you maybe introduce corrections that are in competition. And so you often end up with something that is very imposed with multiple solutions and so on. And so we developed a special technique in order to map your unknown parameters into a new space where you can identify only those modes that are visible, and then you identify those, and then you map them back in the physical space. So by doing this, we can also live with correction terms that are redundant, if you want, and that not all necessarily visible. So you only identify what is visible in the data set.
Thank you. Super interesting.
Yeah, thanks.
Okay, Gregor, so I think we are done with discussion update on work package 1.
Lovely. Next part on the program would be work package 2 then.
All right. This is Andreas speaking. Can you hear me?
Yes.
Okay. Yeah, I also have a very brief introduction and presentation. I like to share my screen now. Yes, I'm quite new in this FarmConners project. I took over the work package lead from TU Delft beginning of this year in January, and work package 2 is, wait, I go to presentation mode now. Better now, yes. And we are dealing about certification and standardization, and it makes sense that we take a leading part for this work package. And then beginning of this year, Corona appeared, and it was a kind of delay. However, we have been working on the first task, the regulatory issues. We have a second task, certification issues, and finally, at the end, we should prepare some proposals for certification and regulations that might be introduced into the IEC, that might be introduced in DNV GL standards to make farm control applications acceptable for both OEMs and wind farm operators, and pave the way to the market, as it is a goal of this project. For the first task, we have a deliverable, which is a position paper looking at the current situation of standards and certification regulations for farm controllers, and we can see that there isn't much right now. It is quite a gray landscape in the regulatory issues, and I think one of the main reasons is that the development of those farm controllers are still so various that you can't press them in some uniforms specific packages and standardize them. However, we have identified some possibilities, and we have been working in the previous project CL WinCon, and we have also worked in or we continuously working in farm control in the research project, and we have developed some proposals how standards can support farm control. One thing I would like to address here as a partner from DNV GL, so we have our Bristol colleagues. Renzo just introduced himself from Bristol, who works technically on supporting farm controls, and we in Hamburg from the renewable certification work on the regulatory issues. And what my impression also from this first meeting we had in Leuven was the load impact on the individual turbines due to farm control activities is still very unknown. How much impact does wake steering has? How many starts and stops we have due to adaptation on market price regulations, downscaling, power reduction, etc. How this affect the overall loading. This could maybe have even benefits. I will show that later on, but it might have also individual increase of some loads with respect to their type certificate or project certificate. So the limits that have been once frozen in the design. And I think this is the important point we have to figure out in this project, how the loading impact on individual turbines might be in a wind farm which use farm controls, and those benchmark tests, I think, and the testing, field testing, will bring here a very important impulse. Okay. Yeah, right now we are working on the paper standardization regulation issues on wind farm control. We have in there a description of the current landscape. We introduce again the market structure, which has been provided by work package 3 by Kontanze. Thank you very much. We introduce again and give an overview on the strategies of wind farm controls, and we propose some solutions how farm control algorithms could be certified. We see here two different strategies. One, I would say, would come from the traditional way of certification. We look at the loads by measurements. There is, for example, the possibility to issue a certificate, a project certificate for a wind farm with conditions, a conditional certification. This is often common practice if some not safety relevant issues have been shifted further out and will be submitted later on. And here for farm control, we could say the farm operator should demonstrate by measurements that the loads on their turbines during, let's say, 2 years of operation with wind farm control do not exceed any limits from certification, from project certification or from type certification of the turbines. And if we then can analyze those load data, compare them with the original design limits, then we would issue the final certificate. So this is one approach, and this one will be recently introduced in our DNV GL service specification for offshore wind farms as an option. So here we have already directly the impact here from our research results into a international published standard. In the IEC standard, still there is not very much mentioned on wind farm control. The second approach we introduce here in our deliverable is the risk-based certification. And risk-based certification is a general approach for novel technologies. For example, in floating, in tidal turbines, we have designs which can't be certified with existing standards. So you apply a failure mode risk analysis, FMEA or FMECA. And this is a experienced and established process to decompose your system into subsystems, look at the failure modes, look at the consequence of those failure modes, and all those consequences you identify, and typically you use a number of experts from different fields to get a broad picture of consequences. You rate the risks of all those consequences and sum them up, and you get a quite good picture on where you have to look specifically, where you have high risk in the system or low risk. And then you create additional measures how to mitigate those risks, and those could be further inspections, higher inspection intervals, monitoring, prior testing, etc. And this risk-based approach is also already introduced in DNV GL standards. We have a recommended practice describing this process, and I think this would be, at the current stage, one of the favorite ways if, in fact, a real wind farm, a operator would say, I would start with wind farm control. I would bring in the software into my wind farm, and I would like to receive a certificate, a project certificate for running this wind farm with farm control algorithms. Okay. Then I'd like to show briefly here levelized cost of energy, the overall motivation for farm control. And in the other work packages, we get the money or the benefits out of increased energy yield here and reduced by AEP, my levelized cost of energy, or by an increase of financial rates. However, there are some other different impacts on the levelized cost of energy, and this is the availability, the reliability of the wind turbines, and related to that, the operational and maintenance costs. And to show that here, typically certification would create benefits. Those benefits, however, would not be visible right away, like the increased energy production, which you see right away in the euros you sell in energy, but in the long term, and availability and reliability impact also the operational costs and the OPEX. And yeah, there has to be a balance that you produce as much as energy you get out, but have a look that you do not decrease, for some reason, availability by overloading some specific components, which then have earlier failures and have to be replaced, and increase our levelized cost then maybe at the later point. Yeah, this is our current stage. Our deliverable D21 will be delivered beginning of July, so very soon. And there is the second deliverable, the certification workshop, which has been shifted due to the Corona delay of the conference, Wind Energy Conference in Hamburg. This conference will take place now in December, 4th to 8th December this year in Hamburg. And together with Gregor, we will create a workshop there. And we hope then we can already introduce some further proposals on certification issues. Okay, that's for my part. Any question, please?
Yes, Andreas, this is Carlo Bottasso from TUM. Yeah, I have a question regarding the certification process. So based on a lot of discussions in the recent years, lots of possible partners, I see a big difference on whether you work on a wind farm control project with the collaboration of the original designer and manufacturer of the turbines, or whether the designer is not present. And so in that case, you don't have a detailed elastic model of the turbine, and you don't have access to the control system and so on.
Yeah.
So I think it's important that there is a path to get a certificate also in the case where the designer of the turbine is not on board.
Yeah.
Maybe not even present on the market. So I understand that maybe your option one, you described two possibilities, right? So your option one should also cover this possibility, right? Did I understand? Did I understand correctly?
Yes, this one, the temporary conditional project certificate with measurements. Yes, indeed. So if we do not have access to the simulation, to the turbine models, however, if you operate a farm, you own at least the certificates. When you have bought the turbines, you also receive the type certificate of the machinery, for example. And in this certificate, you have a detailed list of the boundary conditions allowable for the turbine. And you will take this as a basis for then comparing with measurements, for example, against those design limits. So even though you have no cooperation with the turbine operator anymore, I would say this, which is very seldom, because in somehow you have reliabilities contracts, you have warranties with the turbine operator. So there is typically always a contractual relation between a farm operator and a turbine supplier. But indeed, this first solution would then cover this situation, yes.
Okay, thanks.
Yeah, so again, I'd like to bring in here the keeping back in mind that all changes we do in the control of a wind turbine means a change of these, however it looks like, load spectrum that turbine then will see over lifetime. And this change of loading spectrum must be somehow captured and evaluated. So to mitigate the risk that this load spectrum not exceed and damage some components at the end. So this would be also a challenge, that beside this innovative strategies, we have a look back, how does those strategies impact somehow my overall lifetime load spectrum for the individual turbine. Yeah. So this is the overall summary. The message we would bring in here to the other work packages as well, and support on reliability and operational costs. Okay. Filippo, then I hand over. Maybe I'm short in time.
Yes, but that's actually not really a problem. I'm sure we all have some possibilities to spend some extra time. Should we end a bit early? And if it's just getting another coffee.
Maybe I can. No.
Yeah, if you don't have any more questions, I mean, but it didn't seem that way. So the agenda would mean that after work package 2 we have a break. We can have that either now.
My suggestion would be maybe we could have a short discussion with the other work packages 1 and 3, where in this project could be connections to get the picture of the loading spectrum of the wind farm. So one has been addressed by Tuve with the benchmark tests and the field tests. I think this is a good way exemplary demonstrate how the loading spectrum deviates maybe from an original loading spectrum, and on the market side, what could be typical scenarios of market price changes and stock market impact on downtimes and on starts and stop procedures, numbers on start and stop procedures, etc. That would be interesting for me, for example.
By all means. Do you have any input to that?
We are also in work package 3 on the markets. We are designing showcases, and actually we will come to that a bit later today, but also tomorrow we have a work package 3 meeting where we will discuss this in detail with the consortium, which cases we should include and what makes sense. Andreas, I'm not sure, did I invite you for the meeting tomorrow?
No.
I will do that. So maybe if you have time, you can join, because then we will today just give a brief introduction, but then we want to have a more detailed discussion tomorrow. But I think it's a good point, and we should see if we can also kind of include start and stop procedures in the results that we will want to get there.
Yeah. Okay.
But Andreas, maybe a small comment, because you refer back to the benchmark, right? Within the benchmark, we do have the load alleviation cases, and we also have the power maximization cases, right? Where we're looking at the power gain. And so the thing is, when we are actually aiming for the power gain, there's a risk that the loads will increase. We are not necessarily looking at that in the benchmark, but I'm hearing it might be a very good idea, at least where possible, to have a look at that too. So let's say, just to give an example, right? We are looking at a power gain with median around 5% with the spread, let's say plus minus 5%. And then how does the load per turbine look for that particular scenario, right? According to that particular model results. Then we're looking at where we are in the sort of load envelope. How much of the gain, again, basing that on the usual normal operation load envelope, right? That's what you would like to see.
Yes.
Okay.
And there's another point which maybe looks not obviously at the first point, but also power reduction might lead to higher loads in terms of less aerodynamic damping if we have only idling or much more idling situations due to some control issues. We have an increase of maybe tower bending moments due to lower idling. So typically operating is a good stable condition for wind turbines, and sometimes power increase not necessarily means higher loads. We see this in many commercial projects where OEMs offer so-called boosters. They improve the aerodynamics, they improve the control strategy in the rated wind speed area, and they achieve more power, more energy output by maintaining the load level. So this is possible. So it has to be checked. That's my message. It has to be checked, either with the downrating and with the power increasement.
Yeah. Okay. Then a follow-up question to you, maybe. Is it going to be any section in the position paper that we refer back to? For example, when we are doing the optimization in the end, we can actually bond for the loads, right? So we can say, let's not allow anything more than 10% increase or something. Is there a certain reference we can go back to?
This is exactly what's so difficult. So therefore, we do typically individual load assessments, and also on every site we do site-specific assessments in the real life. Right now, every wind farm which will be equipped with a certain wind turbine will be checked with the conditions on those sites again, although the turbine has been certified already for class 2 IEC wind class 2 forever. And from the first point of view, the wind speed of class 2 covers the conditions at the site. However, the complex relations make it necessary that you check every farm conditions on site individually. So I fear that we will not be able to give some overall levels. I know that we have some limits already in the load standard, which saying at which degree of change of my turbine design, my certificate has to be updated. This is for change in rotor diameter, and I think there is also a factor on the rated power. So maybe we could refer to those limits then.
That would
There's
be
a linkage.
useful. Yeah, that would be very useful. If you can have that in the position paper or any of the deliverables in work package too, that would be really useful for the people who are setting these objectives for the controllers. Yeah.
Yeah, thank you. That's a good input.
Beautiful, thanks.
This is Nikolai from DNV GL. I have another input or question to the meeting of work package 3 for tomorrow. I would also be interested in how much the impact of grid code requirements to wind farm could be in terms of loading. We are mainly talking about ancillary services, market-based impacts on the wind farm and the loads, but if the network operators send requests to the wind farm to continue operation in case of a grid fault or to stabilize the grid, reduce power, increase active or reactive power, that could also have an impact on that.
Yes, so I will include that in the notes that we can discuss it. So far, we kind of concluded that it makes more sense to look only at the electricity market right now, also because we look at wind farm flow control and the timescales. We thought that it would make more sense to look into this, but we should definitely discuss it if we should look into ancillary services also in work package 3. And so, do you also want to join the meeting tomorrow, Nikolai, by the way?
Please send me an invitation.
Yes, I will.
I'm not sure if I'm available tomorrow, but let's see. Maybe this aspect is not in terms of time not so important, the code requirements, and but in terms of certification it will have an impact, and I think will affect this whole certification construction, and so we need to address that as well.
No, I totally agree that we should also combine like wind farm flow control and the grid control aspects. It's seems a bit separated in the research. Yeah.
Good. Any more questions or inputs? If that is not the case, then we are having a break scheduled for 10:25 until 10:40. So let's push that 5 minutes ahead and reconvene at 10:35. Tuve, can you pause the recording?
Yes, okay. Good morning. My name is Anna Maria Sempreviva from DTU. I'm the leader of this unfortunate work package because mobility is not really actual at the moment. But anyway, we try to climb the mountain again. And you can see there are some keywords there: efficiency, support, networking, and these are keywords for the mobility program for this FarmConners project. Then there are these, I will just remind you what are the objectives. I mean, it's improved communication and efficient transfer of information, efficient implementation of the work program, and to facilitate the cooperation between FarmConners researchers. Some example is a jointly writing paper, design benchmarking, which actually has been the only mobility that came out was that was founded was design benchmarking, or choose a detailed discussion or case studies. It's a part of the open science kind of wave now. The mobility now the wave has been stopped, but I just remind you that there are two funding schemes. One for managers, which managers means also the work package leaders, less than 1 week or up to 1 week, and then the seniors or PhD, but between 1 week and 2 weeks. And the financial model is people get 200 euros per day, and then a lump sum of 600 euros to travel, but no salary is covered. The salary is meant to be given by the project, FarmConners, for instance, or parallel projects which you have at your own institution. And the deadline is running, is a running deadline, and you can submit the application at any time. And yeah. Yeah, it's the application form. We have a template. It's maximum 3 pages. It's not really a big issue. The project overview and objectives, the topics, originality, innovation, methodology, implementation, national project involved, benefit to the advancement of FarmConners objective. This is important. Which degree of transfer of knowledge to the other participant you bring, and then level of fairness of the data then the project, the mobility producer. We come back to the fairness. And then there will be an evaluation committee, which will be me and one topical expert. Actually, I really thank the topical experts, the colleagues that agreed to review the application. I will not say who because it's confidential, but they know. Okay, the activity, well, there has been one application and several inquiries. The application was sent by Kontanze Kölle from SINTEF to DTU, and then she went to DTU 23rd, 28th of February, just before the closing. It was very lucky. And I asked Kontanze to actually give a kind of comment about her mobility.
Yes, I was allowed to visit DTU, and it was a really great experience, I would say. So yeah, we worked on the benchmark and on the papers. It was mainly me and Tufa sitting at her desk, and I found it really helpful to have a direct discussion and write it there together with her. And we also planned a little bit how to continue with work package 3. And I would say all in all, it was a really positive experience. And I would encourage people, if it's possible again, to travel to visit other partners and really use this chance to visit other institutions. And of course, if you travel further south, the weather is always better. So try to do that.
Yes, thank you very much. Then you will be our testimonial. Okay, then she already said what she has done. She succeeded with the TUFE to reach her goal. And well, these are the deliverables. They are far away deliverables. The first is the activity report. And then there is something which is called lecture on added value on mobility skills in coordination action in Europe, just to transport what we have done to other projects. But I'm not sure how we can deal with this. Then there is the final activity report. One thing is the problem is that we have a budget of 100,000 euros, and I'm not sure that there will be so many people to mobile people, but I mean, I really encourage everybody to apply, because it's quite nice, as Kontanze said, it's a quite nice experience. And so if you have any ideas to use this part of this budget, it would be, we can, I mean, with Gregor, we have talked about this, and we can consider the idea. One idea that I got is that we talking about fair data, which is, I mean, now I will introduce it with big kind of sharing data and making data findable. This is findable, accessible, interoperable, and reusable. And this will, what the Commission like to do, that all the data that come out from projects, we come out with some databases which are shared, and then because as it's written there, other people's ideas can meet your data, and that will ensure visibility to your data, efficiency of work, because people and yourself, if you can access other people's data, will be more efficient, and then it will be a networking, because you will meet different other people. And then not last but not least, in this we might, I mean, the project might use this ShareWind portal, which is the data registry, where all the data sets can be registered, and they mean that there is some metadata that one can assign to the data sets. But if you want more information, then I can come with more information. But for the moment, I think I stop here. Gregor?
Yeah, thanks a lot. Were there any questions on the mobility work package?
Hi, this is Irene from SENER. Thanks, Anna Maria, for the presentation. Have you received any comment from the European Commission regarding this kind of mobility schemes, taking into account the situation with the crisis, COVID crisis?
Not yet, but that's part of what we with Gregor should do. I mean, if we collect some ideas, more ideas about what can be used this budget, we might approach the scientific officer to tell him this. But I'm sure that he's aware of these troubles.
Yeah, I do have a slide on that in my presentation.
Yeah, okay, fine. But I think the application is quite painful, I mean, because, and then also 1 week is not really a big issue. But the problem is that, I mean, can we move? Do we dare to move? I mean, we are all home, so it's, yeah, that's a major problem.
But Anna Maria, a simple solution would be to just get an extension, so to have more time to use this money.
Yes, that's what was one of the suggestions.
Yeah, without having to invent new ways to spend this money, simply get more time. I think that would be probably the best solution, or an easy one at least. Yeah,
I agree. I agree.
Okay, Anna Maria, if you stop sharing, then.
Yeah, I do.
Because then we're directly in the work package. Here we go. The work package 5 discussion, and exactly, we get two ways out as I see it. Either we use the money for something else, which could be partly that fair wind, a fair data effort on the ShareWind platform, and partly we extend the project. And I'm quite partial to get another 6 months or so for the project. But I also think the right point for asking for that and for discussing all that is we're having the midterm assessment with the EU in month 15 of the project. That's in November. So up until that time, I think we should have those discussions and try to make a plan for what we do in the future. I can obviously talk to Dimitris before that, and that I already started some of the discussion on it. But that is, in my opinion, that midterm assessment would be the right time to get all of this. Also because in November, October, November, we should have a bit better impression of whether that's a thing that continues with the COVID-19 crisis, or whether there's some light on the horizon that makes it different and makes travel a bit more possible again. Let's see. So in short, I would push that to well after the summer, that discussion. Then the other thing for management is that energy is, I think from 1st of July, RWE Renewables GmbH. And that in principle, we thought it might need an amendment, but we've had a discussion with Dimitrios and found out if it's a universal takeover, and we try to figure out what that actually means, then we actually don't need an amendment, and that would be a good thing too. So then all the rights and obligations from this project would just be taken over one-to-one by the new company together with the personnel, and then we don't need that. But
David, can you hear me? Maybe,
yes.
Maybe a comment?
Yeah.
I don't know if that clarifies it, but so Energy SE is obviously a very large company and has a renewables business, and only this renewables business is going over to RWE Renewables, whereas the rest of Energy is merged with E.ON. So I'm not sure if that is then considered a universal takeover, and whether our contract is mentioning Energy SE or the renewables business of Energy SE. So maybe that's the question that we need to answer here.
Okay, good. But that's, I think, up to your legal team for the moment to figure out what that means. Because you probably are in several EU projects, so that must be the same for all of them.
Yes. Yeah.
Good. If you don't have any more questions to the management, we need a yearly report, but Christina is going to instigate that one. And that's probably mostly the work package leads that need to come with some input there. And that's also after the summer. Were there questions?
Well, I do have one question to Anna Maria for the mobility. But by the way, it was also great, and from the host perspective. So it's great to travel, like Kontanze said, but it's also great to host people. It was really nice, very beneficial in so many ways. But my question is, does it have to be a single person at a time? Because I'm thinking, for example, for the benchmark organization committee, namely me, Filippo, Irene, Toma, can we actually all apply and go to one particular place where
yes.
one of us is the host?
Yes, it's possible. I mean, why not? I mean, there was in the IRP Wind project, there were the management, for instance, went to Rome to discuss about, and actually they moved from one institution to the other to make a strategy plans.
Okay.
Oh, so I will say that it's the same for this. If you have to work on an issue that is needed some decision to the group decision. It's very good idea actually to do it.
Okay, good, great to know. Okay.
I mean, there is nothing that prevents this.
And it's still minimum 1 week, right?
Yeah. Well, if it, for instance, there are the work package leaders that meets, or task leaders, they can be considered as management, and then they can stay 1 week or less than 1 week. But I mean, I would advise to stay for 3, 4, 5 days, because then really it's the work is getting done, because a 1 day meeting it's not mobility, it's 1 day meeting.
Yeah.
Thank you for this idea.
Gregor, hello,
Yes.
Irene speaking from CENER. For the reporting, the midterm reporting, the financial one, which will be the dates expected for finishing this, in order to let our financial department know in advance, you know, always
Yes.
they need some time.
I don't know whether Christina is on the call. Otherwise, it would probably be after month 12 that we can try to get that. I think we have month 12, and then the cutoff is 90 days, or no, 45 days probably, to get the financial statements from all the partners. And we started the project in wasn't that September? So it would be at the end of August that we come with some requests.
Okay, perfect, thanks.
So we don't actually have a point in the program here for work package 6, but I'll take that time anyway. Johan, Jan Willem, Paul Fleming, and others, and me are going to propose a wind farm control mini symposium at the Wind Energy Science Conference in Hanover. And that's modeled very much after the thing that we had in Cork as well, because we thought that was a good way of doing it, and we got quite a lot of good responses. So we thought that should just go on again, and from FarmConners, Total Control, a lot of other projects, we're probably getting quite a good group together again. Then Andreas already mentioned we're going to have a side event in Hamburg on certification. That is back-to-back with a side event of Total Control, which also has promised to show some results. And the Hamburg conference, as you probably know, has been shifted from September to December. Yeah, but let's see what how travel is by that time. And then other interesting news is that on the recent EXCO meeting in May of the IEA Wind EXCO, Jan Willem and Paul Fleming presented a new task proposal for a IEA Wind task on wind farm control. And there's already quite some collaboration going on with that. And from the way it was treated, it sounded like now over the summer, there should be a full task proposal being developed. That one was more of a teaser to the EXCO. And the full task proposal would then be probably just accepted by the EXCO, and the new IEA task could then be in operation towards the end of the year. So that would be quite an interesting thing. And of course, while FarmConners is running, we have a strong collaboration with FarmConners, because it doesn't make sense to have yet another workshop at yet another location from a different project. And I think that closes it for me. Any more questions for dissemination?
Yes, I have a question about this mini symposium, because in work package 3 there are 2 presentations supposed to be at that symposium, and I'm wondering if they have to submit it as a normal abstract or if they can sneak in as invited speakers.
That's a good question. I would say we are doing a call for abstracts, and then it's probably Jan Willem and me who choose who gets to talk on the conference. So I would say, don't worry.
Okay, it was more about like deadline-wise, but okay.
Hi, Gregor. I have a question regarding the site event. You mentioned that this is a back-to-back event with total control. The difference in content so that we do not double issues content in the meetings.
I'm organizing both of them, or co-organizing both of them, so I'll make sure that there is no overlap. But total control is very technical in its total outlook, so it's not going to have a lot of overlap.
Okay. So yeah, then maybe then this is good combination to have the technical and the certification parts next to each other. But will they be also time-wise at the same time, or does the people have to decide whether go for farm control or FarmConners?
That's what I mean with back-to-back, that we have 2 workshops in one session, and the next workshop in the next sessions, next time slot at the same place. So that people can stay there if they want to, or
have both.
Yeah.
Okay, fine. Thank you.
Yeah. Good, and then I think we go back to Konstanze.
Yep. Can you still see it? Yeah.
Yes.
Okay, great. I haven't used Zoom that much. Okay. Yeah, work package 3, you might have realized, is now at the end, although it should be in the middle. And that's because Kaushik should present something at the end, and I hope he joined or will do this soon. Okay, but first some general information. So work package 3's title is Electricity Market Integration, and the objectives, according to the proposal, are to further motivate the faster and more efficient commercialization of wind farm control. And the focus there is on ancillary services and which benefits you could get from wind farm control takes care of that, and also if there is an economic yield increase to get. So the sub-objectives are to investigate the state of the art. That would be, okay, which ancillary services and intraday markets should be addressed or are addressed, and what is the potential value creation of wind farm control in this setting. The second would be to define market showcases. This is what we talked about a bit earlier. How can wind farm control react upon the variable electricity prices, and how can the wind farm control methodologies provide some benefit there. And the third sub-objective is then to reveal a potential impact of market benefits if you include the design phase. If you look at the work plan, there are 3 tasks. First is value creation, which is already finished. The second one is on market showcase. So this is going on the whole project period, and we are working on that right now. And the third task is then the design phase, and this will start soon. Now I will go through each of the tasks separately again. So task one was basically the workshop in Leuven, where we discussed market challenges for wind farm control and how what could be the potential value creation there. And here just a picture of the participants. We were 33 participants in total, and 8 people joined online. And I think we had a great time, had interesting discussions, and also KU Leuven did a good job in hosting this event. So with that, the first task here in the work package was completed. The second task, this is one of the ongoing tasks, well, it's the ongoing tasks, so there the idea is to build market showcases to investigate the advantages of wind farm control in variable electricity markets, and to demonstrate how wind farm control could provide a benefit there. And the idea is to test models and control strategies on variable electricity prices. And that's right now, there's was a subgroup of us working on defining showcases, which then hopefully could quantify the advantages of wind farm control in flexible electricity markets. And just as a little teaser, so the idea we have right now is to use a reference wind power plant. And in this case, it would be the total control reference wind power plant with 32 10 megawatt turbines. And that's not actually located west of Honsref, but this is now the reference location we are discussing right now. And the idea is to provide electricity price series and weather series, and then define showcases. And the main cases we are thinking about right now is to have low electricity prices or high electricity prices. So how should then wind farm control react upon this? And as a third showcase, we were thinking about TSO driven. And this is maybe actually where Nikolai's comment could get into, okay, what if you have ancillary services and how is it then? And the idea is tomorrow in this work package meeting to present you the details how the electricity prices are generated and also the weather data, and then to discuss if we should define for these this benchmark the control objectives. So for example, should we say, okay, they should do load alleviation if there are low electricity prices, and also to discuss what are the measures of interest that we want to look into. So do we want like load limits included and then look at the revenue and things like this. And now I just realized when I said they, the idea is also to release this publicly so that everyone can participate that would like to do this. Yeah, and then the next task that will start soon. This is now a slide actually prepared by Thomas from NG Green. So NG will be leader of this task. And the idea is that so far wind farm control focused always on the operation of wind farms. And the idea is to, okay, what could we, if we consider wind farm control more in the design phase, what could have this as of an influence on the wind farm layout and design. And this task will also be discussed at the mini symposium at the WESC next year. And at the end, there will be a report that summarizes the discussion and other results. So we will also, tomorrow, Thomas will talk himself about it and what he plans to do there. And yeah, so but this is now starting up right now. Then if we go to a summary of the deliverables, The first one, this is which is screen marked, was the workshop in Leuven that was done. Task 3.2 has 2 deliverables. The first one is what we are working on right now. This is the definition of the showcases, and this will be submitted to the wind integration workshop this year. Then also discussed the RESC next year together with some results that we might have at that time. And then at the final project meeting, we want to have another discussion and merge the results before it's then sent to final publication in some journal. Yeah, and as we showed before, task 3 will also start because there will be some discussion at the mini symposium, and then we have a publication. And are there questions about this? So any of it? Okay. That is really great because Kaushik is here. So I will give the word to Kaushik because he can't join tomorrow. So he will present already today how the time series for the electricity prices are generated. And then we will have a short repetition tomorrow before we and tell you about the rest we plan. And then we hope that you will participate in discussions. Okay. Kaushik, just let me know when I have to switch the slide.
Yeah, thanks, Constanza. Yeah, I think most of you were present in the Leuven meeting. So this is sort of a subset what I had presented there, but just to recap and what we are using in the FarmConners meeting. So we can move ahead to the next slide. So we at DTU have a modeling toolchain or balancing toolchain as we call it. So what we have there is that we have a power system scenario, like how the future might look like, and the focus is North Sea countries, and I'll come into details of each of the blocks again. And then how the future technology as well as the energy system might look like. And then that feeds into our other models. And then on the top also we have CoreRes, which provides the correlated wind and solar time series and forecast simulations, which we use in our other tools. And then we have the energy system model in Balmoral, which is openly accessed and is very well known. So in Balmoral, what we do is basically we run the unit commitment model. So that's how much power generation we should, all the generators should provide, considering all kinds of technical constraints, as well as in order to minimize the cost of generation from the system perspective. So for that, that's done day ahead, and then for that we need the day ahead forecast simulation. So using the day ahead forecast simulation, we run that, and then that provides basically the bid or the dispatch of all the generations, including the wind power plant. So wind power plant will be dispatched based on their day ahead forecast. So once we have the schedules for the day ahead, then we come in this is based on the Danish principle of balancing. Then we come into the more towards the real time and the regulating market. So this is 1 hour before the operation. So we get an hour ahead forecast from the CoreRes on the top. If you can show, please, Constanza, that's the hour ahead forecast we have. PVREHA. Yeah, that's the exactly. And then we compare how much we have scheduled. And then based on the imbalance, we see that this is what we had the day ahead forecast, and now we get the hour ahead forecast, and then we see this much imbalance. And then they activate those reserves, and based on the available resources in the system, that fixes the price of up regulation and down regulation. And then further comes the real time, where we have the primary and frequency or frequency containment process, frequency restoration process, and all those things, which is sort of out of scope of this project. So I'm not going to go into details of those, but those are the real time activated reserves either from any kind of generations or wind power plant maybe as well in future. Okay, please move ahead to the next slide. So looking at the power system scenario, so these are all the market areas we have considered in this balancing tool chain. So we have mainly the North Sea countries, and then we have two kinds of scenarios, and I have put some links, so in case you want to go into details about this. One kind of scenario is like project based, or another is offshore grid. So in project based, so all the new offshore wind power plants are just connected to the shore, to the nearest connection point, and the offshore grid is basically looking at the offshore grid rather, in order to minimize the whole investment cost and to maximize the energy production from all these generations. So both the solutions have been looked into, and then we simulate the core race from the core race, the simulations for wind and solar power, and then that feeds into the BAL model here. This BAL model is not the unit commitment, but rather the investment optimization. So we look into how much we can put in 2030 and 2050. So we have integrated investment optimization there, and that provides us the scenario: what is the installed gigawatt and how much is the annual energy production, what kind of generation technologies would be there in 2020, 2030, and 2050. So those are the three scenarios we have. So can you please move to the next slide? I have 5 minutes, isn't it, or a bit more? Sorry, you are mute, Constanza.
I don't think that time is a problem. Okay.
So then we move to the core race. So core race, like I mentioned already, this is simulating the simulation tool we have inside DTU Wind, and this can model both wind and solar PV, and Matti will be there tomorrow, so he can also talk about core race more detail. And then this is based on 37 years of meteorological reanalysis models. So we have quite, so this does not, so that's why we call it forecast simulation. This does not provide how not yet we are working with the climate change aspects and things, but this basically looks like what the historical weather has been, and then on top of that we put the stochasticity of the forecast errors. So that's how we get that this is how the wind power had blown in certain year, and this would have been the forecast. And then we assume for all the future simulation that the weather or meteorological aspects remain the same like it was in the past. So for this specific task and specific work, we have chosen 2012, which was one of the high windy year with storms and other things as a base meteorological year, and all those studies are based on 2012 meteorological data. And yeah, so, and in the figure there also you can see the day ahead, hour ahead, and the real available power. So you can see the difference, and this is the motivation that there can be substantial difference in between day ahead and hour ahead, and that's what drives this balancing principle what we have in Denmark. That's what Energinet does, and this is developed based on Energinet's principle. So can you go ahead to the next slide, please? Then we run the spot market model, and then all the results are again in the link. Oh no, this is the methodology is in the link, and this is very complex model in terms of making it run, because as you could see, it's a very large system with almost I would not say Europe, but quite a large portion of the Europe with a very detailed market areas and everything. And then we need to run it because we need to run it for planning studies here. So we need to run it for whole year. So we have to do many kinds of, generally it would, since the unit commitment constraints are like unit on and off. So these are integer programming, and that is mixed integer linear programming. So that takes quite a lot of computation, and probably it's also not feasible to run it. for that much, that big area. So of course we could run it, but then we had to make some relaxations, and all those mathematical details you can find in this paper, which is under review. But the main objective is to, in the spot market model, is to emulate the spot market behavior in the, either in the Nordic or Denmark or in Germany or all those places. And then the objective is to minimize those costs, which involves a fuel cost and operation maintenance cost, emission cost, and fixed costs, as well as unit commitment cost. And there, one of the major challenges is the emission cost. And because we do not know how that cost is going to be driven in the future, mainly because this is regulation based. So we have increased the CO2 prices in future. And then also based on our studies, we see that in 2030, the wind is increasing, but CO2 prices are also very increasing because there are still substantial coal power plant in the system in 2030, and which is probably not that far off from the real system, because of course these are prognoses, but I mean, looking at today, we still have quite many coal power plants around in Poland, in Germany, in many other places. So that would be staying. And then one way to drive the renewables is to increase the CO2 prices. But what we see beyond 2030 is that now the wind power plants have increased substantially. As a result, the system is more green, and then also we see more and more decommissioning of the coal or thermal power plants in the system. So that also reduces the carbon tax or carbon prices. So this also drives quite a lot on impact on our results, because there are two things. One thing is the unit commitment constraints, that whenever they are on, you have to have the minimum on off time, and then shutdown startup costs as well. But another thing is the carbon dioxide and also the NO2 costs, NOx costs actually. So for the emission costs, so they also drive quite a lot these results. Okay, so can we go ahead to the next slide, please? So this is the cumulative price distribution we have for all these scenarios, 2020, 2030, and 2050, for both scenarios, project-based as well as offshore grid. And what we see that the price becomes very much volatile towards 2050, but generally the prices are increasing from 2020 to the 2030 scenario, and then again going down in 2050 scenario. That's what you can see from this slide, and this is exactly because of the reasons I mentioned before. But also we have a high amount of hours with very low prices, mainly in 2050, but also in 2030. And this has been the motivation for us in the FarmConners to make those binning. I don't know if Tufe has already presented the binning, what we are doing for low prices, high prices. So, but we can see that there are different regions in the price where we can operate either with a high wind or low wind, and high prices and low prices. And can we go to the next slide, please? And all the results are in the link below. So, and then I think we have also presented quite a lot in the Leuven as well. So also we looked at quite a lot, quite high volume of curtailment we can see from wind power in 2030 and 2050. This is but the reason for this is that also in 2050 we have substantially increase in wind power penetration or wind power share. So even the number of terawatt hours are increasing, but the percentage wise they remains remains same. But even that's 6% in 2050 what we get to see. So that also gives a different kinds of motivation, so that if you are curtailing, maybe we can do some different kind of optimization, like load reduction and things like that. So that's another motivation for the FarmConners project actually. So can we go to the next slide, please? And then we included sector coupling with that's mainly the heating sector in, and then we can see that the curtailment reduced by 90% by 2050 when we have massive sector coupling. All the heating has been converted to electricity. We have also a very limited amount of EV here, and we are still working on integrating the transport sector as well. But that also shows that probably when we have much more much more sector coupling, then there would be probably much more scope of adding renewables in the future as well. Can you go ahead, please? Then we do the balancing, and this is the same principle, but the prices levels go down because this is some up regulation and down regulation prices, but we have the same trend what we get to see in the spot market prices, because basically the up regulation down regulation is driven by the merit order list from the spot market. So whenever there is a room for up regulation or down regulation, all these generators go to the the system operator, and then they tell them that we have this much room which you can use for up regulation and down regulation. But this is what we have bid in the spot market. This is the merit order list. This is how it is done in Denmark. It's a bit different in Germany and other places. It depends on which principle you follow. But this is based on the Danish principle, and that's why we are showing also the Danish results here. And this is also what we are using in the time series in the FarmConners as well, also for our benchmark wind farm that we are providing. Can we go to the next slide, please? And then when we look at the activated balancing, this is done, this is not only for Danish, but also for the continental Europe, also for Nordic, it's in the report there. But because the balancing is done in tandem with all the control areas. So what we see that in the towards 2050, wind also plays quite important role also in up regulation, and this is is coherent with what we saw before, that the wind was being curtailed. So this is some different kinds of market popping up that providing the balancing services because you are already being curtailed. Of course, you can also provide down regulation at any time, and sometimes it's mandatory to get down regulation. That's what also we see in the down regulation curves, that wind is getting down regulated. We should keep in mind that wind is the cheapest source, or wind and solar are the cheapest source. So you would never do down regulation unless you are forced to. So basically, when you are down regulating wind, that means that rest of the generation sources either are not flexible like a nuclear plant, or they are operating at the minimum limit of their capabilities. So that also shows that sometimes it can be down regulated because the TSO forces you to down regulate, because otherwise you cannot. Even if you don't go into the market and you think that you don't need to down regulate, that you might be required to down regulate, and that connects us to our TSO driven case study in the FarmConners, which is more like balance control or delta control in the control paradigm. And I think this was my last slide. Can you go to the next slide? I don't think I have any more.
Thanks, Kaushik.
Yes.
So that was your last slide. Yeah, so that was now how the electricity prices were simulated for these showcases. And yeah, we want to continue that tomorrow and get some input from the rest of the work package participants, which is almost the whole consortium actually. But when I asked for setting a date for this work package meeting, kind of suddenly we got also this whole consortium meeting. So I hope that each institute is represented tomorrow. And otherwise, if you have questions or input, please just contact me or Kaushik Tufe. That's not really important. Okay, that was everything we had on work package 3 today.
So if we don't have any more questions than that, then there's essentially only one more point on the agenda that actually hasn't been on the agenda, but that is the group picture. So for that one, I'd ask everyone to actually open the cameras. And then Tufe will afterwards take the stream and just make a screenshot at the best possible time. So that's good. Now we might want to smile as well. I think that should be possible.
You want us to
maybe do a wave or so. Hello everyone. Good to see a lot of people that actually were on the stream and were listening without making themselves dominant in the discussions. But I hope you all got out of it what you wanted. And then that brings me to the close of the meeting. Thanks for being here. Thanks for your interest. We'll keep you updated on the progress of FarmConners, of course, especially the one that you're doing yourself. You should be updated. And with that, let's see some of you at least tomorrow on the Workpage 3 meeting. And other than that, at the latest in Hamburg at the side event. Bye-bye.
Thank you. Bye-bye.
Bye.
Bye. Thanks.
Thank you. Goodbye.
Thank you, Gregor. Bye-bye.